So I'm going to share my screen with you. Share. I'm going to put this up. And I think you should see it. Hey, Chris, want to move desks? Just so I'm not like awkwardly up in your business. Because I'm going to move
back.
wherever you can pick wherever you want.
It's
just I was putting that right there. It was a little awkward. Okay, sorry, let me just check. Okay, let me go a little closer. Okay, woo. So here's what I want you to do. In your notebook, I want you to write this. This is kind of like the thing that you're going to refer to with all your formulas. So we'll just call these the formulas. I'm going to remind myself to write a little bigger. Can you see that? Oh, that's pretty good. And then we're going to get a new marker just so it's all fresh for you peeps at home. Let me just check. Yeah. Okay. So if I saw you, if you're cohort A, last Monday, Tuesday, if you're cohort B, I saw you Thursday. We talked about these formulas, and this is what you need. So basically, if you have this is kind of the thing you're going to refer to. So we converted from degrees to radians. If that's your directions, you're going to do the same thing every time. You are going to multiply by pi over 180. Okay, so that's the first thing you need to know how to do. I'll go a little closer for you guys. Trying to figure out life today. But once again, if we have everything organized in kind of one spot, it makes it a little bit easier for us. So that's the first thing. The second thing is we converted from radians to degrees. And if you're doing that, you're going to multiply by 180 over pi. So it's just kind of remembering that fraction, but knowing which one to use, because you do flip it. So those are just kind of like our cheat sheet things. And then we had two formulas, so we do need to know these formulas as we go. So once again, having them in one place will make our life easier. The first one is arc length. And the formula is S equals R theta. And I'm just going to make a little note to the side. Theta is in radians. That's why we're doing that in this chapter with all the radian stuff. And S represents the arc length, so if you want to remind yourself that. And the last thing that we need is how to find the area of a sector. Basically, when you think about taking a piece of pie, how do you find the area of that? And here's our formula. A equals 1/2 r squared theta. And same thing, theta has to be in radians. Okay, so I'm going to leave that up for a second because I know when you're at home, just life, it takes a minute to copy, and I don't want to be erasing if people aren't done yet, so I'll leave that up and kind of just remind you of a few things. So these are the main things that we're going to need. So I figured let's kind of organize it in our notebook first. So now you know kind of what you have to refer back to. We will be having some sort of assessment next week, so just as a heads up about that. I don't know what day, because I don't want to do it Tuesday, because that's the day after a long weekend, and then Wednesday is our remote day, and so it'll probably be Thursday. So just as a heads up, the more you have stuff organized, the easier your life will be. So I'll leave that up for another like 30-ish seconds. I'm just going to check and see if anyone else is signed on, just so my attendance is correct. Let's see who I was missing. So no Danny Ferreira, right? Okay. And no JK. Beautiful. All right. So now we have everything organized. Basically, all we're going to do is kind of go through each thing and just make sure we're okay with the process of using those. So are we okay with converting to radians, converting to degrees, or plugging into our formulas? So I'm going to grab my calculator. You grab yours or whatever you got. Remember, we do have to do some like reducing of fractions. So I don't know. I'm going to be honest. I just don't know how great the phone calculator is. With like all that stuff. There's probably ones that you can like free calculators you can get. I'll have to look into it for you. If you don't have a scientific one, just kind of let me know and we can figure something out. But we don't want to do all this work in our head. So we will do our best to let technology do it for us. Okay, so we have all that stuff down. Does anyone still need time with those formulas? Okay, I'm going to take that as a no. You can always write in the chat. I have it right up. Okay, so let's just do kind of, one or two of each type of problem, and then we'll see if there's any questions in the end. For the people at home, I will be checking your notes, so please make sure you do that, and I'll check your notes too, just to give us another grade. And then reminder, if you had any makeup work, I kind of tried to give you the day yesterday for that, but I beat it today, so I'm not giving you unlimited time. So I gave you that time yesterday on purpose. So if you had something you had to get me, please email me if you do it. So I know that I have it and I will update your grade. All right, so first thing, let's convert 285 degrees to radians. Okay, so all you would do at this point is refer back to your little formulas we just wrote. When I want to convert a degree to a radian, I'm going to start with my degree, and I'm going to multiply it by pi over 180. Okay, so that's not a bad step. What happens is the degree symbols cancel, which is what I want. I don't want degrees anymore. I now want radians. I like to rewrite it. You don't necessarily have to. You can kind of do this stuff in your calculator, but I'm going to rewrite it. I have 285 pi over 180. I really just want to see that I want to reduce this. So once again, we said with the calculator, we're not going to put the pi in for this part because we want to leave it in terms of pi. So a lot of times on a assessment, I will say leave in terms of pi. Okay. So just so you know, that's what that means. Don't put pi in the calculator. So I grab my calculator. I do 285 over 180 and I reduce it. That comes out to 19 over 12. And then I just put my pi with my answer. So if you're using like the good old TI, whatever that is, or like these ones, hold on, I just want to do it out. When I do it and I do 285 and I use that fraction button, that little ABC button, 180, it comes out to 1 7/12. That's what it said. If you get that, I don't want mixed numbers. I want improper fractions. If you hit shift or second and then hit that fraction button again, it should convert it for you. So if you're having calculator troubles, let me know. But I do want it in that form, just as a heads up. But that's the first thing. So convert some degrees to radians. It's not necessarily the hardest math. It's just knowing what step to do, multiplying by pi over 180, but now you have it organized in your notebook. Once you do that, just reducing it. So use your technology to help you, and that would be your final answer. So once again, I try to stall after every question. Anyone have a question on that one? Okay. I just know it's hard to kind of keep up at home, so I'm trying to give you a few extra seconds at the end. All right, so that was kind of the first thing that we have written down, how to convert from degrees to radians. And that's a nice example of that. So now let's go the opposite way. That one's Sylvia. Okay. So let's convert from radians to degrees. So if I said convert Right, that would be good. Sorry, my V and my E are kind of combined there. Let me just think of a nice little, nice little, let's do 6 pi over 7. I just made that up, so it's probably not going to be the nicest answer, but we'll go with it. Our main goal from here is, what the heck do we do? I'm sorry, I should say convert to degrees. I'm going to be a little more specific there, Mr. Sherman. Once again, we know this is not a degree because there's no degree symbol. So that's why the degree symbol is very important when you have them. But no degree symbol means it's a radian. To convert a radian to degrees, I'm going to multiply by 180 over pi. So what happens is my pi's cancel. Now I'm just grabbing my calculator once again. I don't want to do any work in my head. When I multiply out those numerators, I have 6 times 180. So once again, I just kind of made this up. That gives me 1080. We have a degree symbol now, right? Because that's there, over 7. So I'm just going to divide that out. Once again, it comes out to some long decimal because I just kind of made that number up. So we'll just round it. I'm going to round it to 154.29 degrees. And that would be your answer for that one. Kind of nice. The pi's cancel. There's nothing too crazy with the numbers. You're just kind of multiplying and dividing. So you use that calculator. And if you get a little decimal, not a big deal. Just round it. I usually go to 2, just as out of habit. So I'll leave that up for a second. We're just kind of going through each thing that we wrote this morning and knowing how to use it. Sorry for the glare at home. The lights always. Oh, Danny, you're London. Waffle. Welcome. Let me mark you as being here. What time is it? Let me just check one more time. Sorry, I'm checking my attendance like 1,000 times today because I just want to make sure everyone gets credit for being here. Okay, just missing one person. We shut it. All right, so we can convert back and forth without too much, hopefully, effort. Just knowing what fraction to multiply by is important, and then being able to simplify it. Okay, so we've done half of kind of our formulas that we wrote down at the beginning. So then we had 2 other formulas that we needed. One was for arc length. So just as a reminder what arc length actually means. It means you have a circle. You kind of think about the radius of a circle, whatever the radius is. Between these 2 things, there's some sort of angle that connects those 2. Finding the arc length is finding this distance, basically the distance of that curve. That's my arc length. We call that S. And to find S, you need that special formula, S equals R theta. Once again, I have no clue why they use actual S there, but we'll kind of go with it. Usually it's some weird Latin word or Greek word or something. So as I'm throwing things into this equation, I just remind myself S is arc length. So once again, it just refers to that curved side. R is just the radius. Okay. So we're thinking about that. What's the radius of that circle? And theta is just my angle. And once again, I'll write this every time. That angle has to be in radians. That's the big thing about this. So if I said find the arc length, if R equals 12 centimeters and theta equals 2 pi over 3. So that is in radians, right? Because there's no degree symbol. What is the arc length? You just throw it into the formula. So once again, it's just more about organizing yourself and knowing what formula to use, when you see arc length, you're going to use that. So let's throw it in. S equals R is 12. And then the angle is 2 pi over 3. And we're going to plug it in as 2 pi over 3 because it's in radians. Now for these, I'm just going to get a decimal answer. So I'm just going to remind myself I want a decimal answer. I don't want an answer in terms of pi. So you're going to find your pi button and actually plug it into the formula. So I'm going to grab mine. Once again, we don't really do these in our head. I throw in 12 and I do times 2. I find my pi button and I put it in, and then divide that by 3. This one can get, depending on your calculator, can get a little annoying. Sometimes if you try to use the fraction button with the pi symbol, it gets mad at you. So it's one of those things you just kind of have to test it. If the fraction button doesn't work, use the divided by button. But I'll leave that up for a second just for anyone to get caught up. Always feel free if I'm going too fast or you need an extra minute, just throw it in the chat and I can always give you a few extra. So there's one other thing I want to do with arc length. It's just one of those I don't want to rush you type deal. Okay, so the one other thing with arc length, so I'll just do it right next to it. Yeah, you should be able to see that. So same directions, I'll say find the arc length. So you can see every time I say it has to be radians, it has to be radians, it has to be radians. So I'm going to give you a radius of 3 inches, but this time I'm going to say that the angle is 210 degrees. So that's the big thing you want to look for is if you're given a degree. Sorry, I'm here. If you're given a degree, the first thing that you need to do is convert this to radians. So don't just start plugging in. This has to be in radians before you plug in. So I'm going to do that first. To do that, I'm going to multiply by pi over 180. So you can look back at our little formulas we wrote at the beginning. That gives me 210 pi over 180. And then I'm going to reduce it. So I just grab my calculator. And that gives me 7 pi over 6. Okay. So now this is what I'm going to use for my theta. So just as a reminder, sometimes we do have that extra step. But let's plug in S equals R is 3. And then theta is 7 pi over 6. So please do not plug 210 there. If you plug 210 there, it won't make sense. So now I grab my calc. I'm going to put the pi into my calculator. Because once again, I just want a decimal answer. So just make sure whatever you're using at home, you understand how to actually use it. Because once again, we will eventually be having an assessment. It comes out to 10.995. I'm just going to round it to 11 inches. So if you round it a little differently, that's okay. But just as a heads up about that, when you see a degree, you convert it to a radian. So I'll leave that up. And then we just have one more thing to go over, which was the area of a sector. And then I'll just kind of check in, see if anyone has questions. I'm just going to do a quick check of your notes today. Once again, that's even for some of you, it's probably better because you're just like done with math and you don't have to procrastinate and then maybe not do it and then not get credit and then say, why didn't I get credit? And then it's a big old thing. So when you're just done, you can move on with your day after that and then have a nice long weekend. All right, so any problems, questions? Does anyone need more time? Pickups. Okay, last thing. So area of a sector. So one thing, I'll just do a quick explanation of what the heck it is. And then same idea here. So last thing for today. So I'm just trying to like the spacing here. So area of a sector. That happens when, once again, we have a circle. we're going to actually talk about circles a lot this chapter. And basically taking pieces of them. Because if you take a piece of a circle, it still looks like a triangle. That's kind of a bad circle, but you get the idea. So it still looks like a triangle. The big thing with this triangle is one of the sides is curved, which we were just talking about, the arc length. So if we said this is the radius, and between these two angles we're given between those two lines we're given an angle. To find the area of the sector, we want to find the area basically of this piece of pie. Area. So to do so, we have a special formula. We had written it at the beginning, but I'll rewrite it. So it's A equals 1/2 r squared theta. So the nice thing about formulas is you can kind of refer back to them and you really just kind of plug in and then you're done. But just as a reminder, A is area, R is radius, and theta is your angle in radians. So we always remind ourselves of that one. So let's say I said, can you find the area of the sector if the radius is 7 centimeters, I'll say, it doesn't really matter, and the angle is 3 pi over 4. So once again, this is kind of the most basic one because the angle is in radians. So you're good. You basically have everything you need and you just need to plug it in. I kind of like these. That's the big thing with trig is plugging into formulas. So my equation is A equals 1/2 r squared. And then theta is 3 pi over 4. So I'm just kind of using parentheses to throw things in. But then from there, you're really just going to grab your calculator and plug it in. It is one of those things where I do suggest you actually try to plug it in so you know if you're doing it right in your calculator, because all of them are a little different. So I grab mine. 1/2, I usually just write 0.5 just to make my life easier. And then I do 7 squared. And then 3, I'm going to put the pi in. So once again, I want my answer as a decimal over 4. So I'm going to find my pi symbol and throw it in. And A is going to be about 57.73-ish. So I kind of rounded that. Sorry, that's a 53. When you label these, it's whatever your measurement is, but that's squared. So anytime you're finding area, it's your measurement squared. So it's kind of the most basic one. You kind of take what you got, plug it in. So we're just going to do one more after that. I'm just giving people a second to get caught up. And last but not least, let's do our last problem here, because it takes me a few to just get everyone's attendance in and then just checking everyone off. Okay, so same directions, find the area of the sector. Sorry, it took me a second to write that. Sorry, just make sure I'm still on the screen. Okay, we're gonna say that the radius is 15 inches and that the angle is 65 degrees. Basically, you can probably see what I'm doing. It's the same thing I did with arc length. The first one, the angle was how we needed it. It was in radians. But the second one, the angle's in degrees, which isn't necessarily how we need it. So the first thing we're going to do is we are going to convert this to radians. You have to do that before you start plugging in. So don't just start throwing things in your formula. So to do that, we have all of our fun stuff to refer back to. I'm going to multiply by pi over 180. And I'm going to reduce that. So most of this I'm just doing with my calculator. It's just normally set up. And that's going to give me 13 pi over 36. What a day. So that's what I'm going to now use as my theta. So that's a big step. You can't just plug in 65. So just as a reminder, and then let's plug it in. A equals 1/2 r squared And then theta in radians, which is 13 pi over 36. And then from there, once I do the setup, it's really just going back to your calculator. I'm going to plug the pi into my calculator to get a decimal answer. So I'm just going to start plugging in. So please do what you can with what you have. But just as a reminder, you might need to use that next week on an assessment. So just make sure you know how to use it. And if you don't, just let me know. We can do something to get you caught up. That'd be squared. But don't wait till the day of the assessment and then use your calculator and say, I don't know how to use it. Then that's where the issues lie. So that's going to come out to about 127.63-ish. And once again, the measurement is inches squared. So I'm going to give everyone a minute to kind of catch up. Sorry, I'm always checking the chat, checking the attendance. Okay, we haven't changed, so I think we're good. I'm sorry, I'll put that in a second. Chris, I'm just going to check your notes while I'm here because that makes life easier. Because then I'll check all theirs. It goes a little longer. You're good. Thank you. Just so I'm giving them the grade. I'm going to give you the grade. Chris. Today.
Miss Sherman.
Hey, what's up?
You know how I said I'm getting like a new computer?
Sure. I don't remember anything.
Yeah, because like I can't do any of my work because it's all on my phone and it like doesn't work on my phone.
Okay.
I just got my new computer because I'm getting it today.
How exciting!
I just got it and it like isn't loading and it's like stupid and it like doesn't work. So I kind of still don't have a computer because it like doesn't work.
Oh, well that stinks.
Because I got it from the school. They told me they would give me one, so I thought it was gonna be like a good one, but it's just